In this video, we will be learning how to apply D'Alembert's ratio test to examine the convergence of a given series. But before coming to this one, let us know what is this ratio test. Suppose a positive series is given to us. This one means the sum of U1, U2, UN, and so on. Now, the ratio test we have UN plus 1. That means UN plus 1 would be here, UN plus 2, and so on. Divide by UN and then take the limit. We will get some value here, say rho. Now, if rho is less than 1, we say that the series converges. But if rho is greater than 1, then the series diverges. And if rho is equal to 1, then the test fails. That means we can't say anything about the convergence or divergence of a given series by applying this ratio test. So now, with the help of this one, let us examine the convergence of these given series. The first one, our UN is n by 2 to the power n. We have to find UN plus 1 because we are applying the ratio test. So n plus 1 would be n plus 1 by 2 to the power n plus 1. Now take limit n tends to infinity, UN plus 1 by UN. Limit n tends to infinity, UN plus 1 is n plus 1 by 2 to the power n plus 1. When we divide by UN, we have 2 to the power n by n. Here we have n plus 1 by n together, 2 to the power n by 2 to the power n plus 1 together. Limit n tends to infinity. This one, we can write it as 1 plus 1 by n. Okay, it means the same thing with this one. And here, 2 to the power n by 2 to the power n into 2 to the power 1. This one is exactly equal to 2 to the power n plus 1. Now, as n tends to infinity, okay, this one get cancelled. As n tends to infinity, 1 by infinity is 0. So 1 plus 0 is 1. And here we have half. So the value is half. Now this one is our rho. Half is less than 1. So if it is less than 1, the given series converges. So we say that, therefore, summation n from 1 to infinity n by 2 to the power n converges by D'Alembert's ratio test. Now the second one also, our UN is n squared by 2 to the power n. Our UN plus 1 is n plus 1 whole thing square by 2 to the power n plus 1. Take the limit n tends to infinity, UN plus 1 by UN. N plus 1 whole thing square by 2 to the power n plus 1. When we divide by UN, we have 2 to the power n by n square. This one is equal to n plus 1 square by n square together, 2 to the power n by 2 to the power n plus 1. Limit n tends to infinity. This one can be written as n plus 1 by n, whole thing square. And here we have the same thing as before. We are left with half. 2 to the power n into 2 to the power 1. So we have half here. Now here, this one, n tends to infinity, 1 plus 1 by n. As n tends to infinity, 1 by infinity is 0, 1 plus 0 is 1, and 1 square is 1. So 1 into half is half, okay, which implies that here limit n tends to infinity, un plus 1 by un is equal to half, which is less than 1. So what can we say about this given series? That summation n square by 2 to the power n converges by the ratio test, by the D'Alembert's ratio test. Okay, let's do the third one. Our un is 1 by root n factorial. So from here, our un plus 1 would be 1 by root n plus 1 factorial. Now limit n tends to infinity, un plus 1 by un is equal to limit n tends to infinity, 1 by root n plus 1 factorial divide by un. That means here we have root n factorial. From the denominator we have root n plus 1 into n factorial. Okay, limit n tends to infinity, root n factorial by, here we have root n plus 1 root n factorial. So they can be cancelled. Now as n tends to infinity, this term here will tend to 0. N tends to infinity, your n plus 1 would tends to infinity, and 1 by infinity is 0. Okay, so this one is less than 1. Now if rho is less than 1, then the series converges. So therefore summation 1 by root n factorial n from 1 to infinity converges by the D'Alembert's ratio test. Okay, let's do the last one, the fourth one. Our un is 1 by n factorial. Now what is un plus 1? It is 1 by n plus 1 factorial. So now limit n tends to infinity, un plus 1 by un is equal to limit n tends to infinity, 1 by n plus 1 factorial divide by un, that is here we have n factorial. Limit n tends to infinity. So here from the denominator we have n plus 1 into n factorial. This one is equal to n plus 1 factorial. Okay, so now n factorial can be cancelled with n factorial, and now as n tends to infinity, this term here will tend to infinity. So 1 by infinity is 0. Okay, and 0 is less than 1. If 0 is less than 1, then what happened? The given series converges. So we say that this given series converges by the D'Alembert's ratio test.